Dear colleagues, I would like to make a report on the topic domain-specific language for adaptive development of smart home application. On this slide, you could see content of my report. Smart home systems are rapidly developed in the last 10 years. It should be extremely flexible and maintainable, and the users must be able to configure and utilize the system depending on their specific needs. Also, it's necessary to say that there is no universal compiler or programming language that provides sufficient functionality for effective control of all components of the smart home systems. The domain of the current research is connected with the smart home system. On this slide, there is a simple architecture of the IoT system. As you can see, it contains several different hardware and software components with own parameters. Hardware components usually developed by different vendors. System's functionality should be available to different groups of the developers and end users. On this slide, classification of some modern methods and tools for DSL development is presented. So there are two types of DSL, external DSL and the internal DSL. The difference is that the external DSL has own syntax and internal DSL use general programming language as a subset of the language possibilities. The important problem of the real-life smart home application development is necessity to combine specific components of different vendors into one automated management system. And the second one is to provide effective support for variability of software components with respect to permanent changes of different user requirements in such systems. To identify the specific smart home application features, this domain model was created in FODA notation. Following the already mentioned trend to apply a model-driven approach to DSL design, we propose to formalize definition of DSL denoted as a tuple of elements FODA, grammar, and code generator, where FODA is a feature-oriented model which reflects variability issues in the given application domain. Grammar is a set of models, algorithms, data resources, and software components which are used in order to implement all grammar services for the given DSL. And code generator is a code engine that converts syntactically and semantically correct DSL code into a sequence of program instructions that can be executed by a target. ITTAP-0 notation shown on this slide. It consists of three functional blocks: lexical analysis, syntax analysis, and code generation. The functional block lexical analysis performs analysis using a constructed FODA model, which includes all terms and constructs that can be used as an initial set of tokens for target DSL. At the end, on the code generation, target C++ code will be received. Grammar rules for our DSL presented on this slide. The main grammar rule will be a rule with the name program, which consists of 0 or more than 0 statements. In this case, a statement is another grammar rule. It can be structured in the following set of the basic rules. Let's look on the simple example of smart home application. A room equipped with a smart air conditioning and temperature sensor. The sensor scans the room temperature, and when it's greater than a certain value, the air conditioner should be automatically turned on. So here you could see the script developed using our domain-specific language, and on the right side you could see how it's compiled in the general programming language. So as you could see, initially it has had only 13 lines, and compiled code has 39 lines. It was chosen the method of estimating the number of lines of code. So we have compared the line of code of our DSL with the line of code with for the GPL, and got 33% score. In the second comparison, we have compared C++ code that was done for the GPL manually with C++ code that was received after DSL compilation, and in this case we got 8%. So to get the weighted score, we have used both values with weighted coefficients and got 17.75%. Our results are listed on this slide. Future work in this research is supposed to extend the grammar of the DSL compiler with a specific rule that will support effectively the variability of software components in smart home system, and to develop a comprehensive methodology for performance evaluation of a prospective DSL compiler, taking into account the possibility costs of its construction and usability for its end users.